Good morning, students. Welcome to all for this session. So, in this session, we are going to discuss about the topic problem solving using C. In this chapter, we'll discuss about how to solve the problem. Okay, and some of the problem solving techniques in order to solve any kinds of problems by using computers. Okay, in first session, we already discussed about the function of a computer. How does a computer works? Okay, and how it solves any kinds of problem that may be a general problem or the user problem, or even it may be a computer's problem itself, right? So computer has emerged as the most useful machine in the recent times. It can perform the variety of tasks like receiving the data, processing it, and producing the useful result. This is what basically the computer do. However, being a machine, the computer cannot perform its own. Being a machine, anything cannot be performed by its own without any kind of instruction. Okay, so that a computer needs to be instructed to perform even a simple task like an adding two numbers. Okay, see, all of you know that the computer cannot do anything by itself unless it has been instructed, so that we need to instruct the computer to do some task. Okay, it cannot do, it's clear that a computer cannot do anything by itself unless any kinds of instruction has been given by the one who uses the computer system. Fine. So basically, uh, the computer work on set of instructions. So those set of instructions are called as a computer uh, programs, when which clearly specify the way to carry out the task. Okay, so that's very important. Okay, a computer works on set of instruction, and those set of instructions are called as a computer program, and which clearly those computer programs that clearly specify the way to carry out the task. Okay, so uh, in this point, it is clear that a computer cannot do any task by itself unless an instruction has been provided by the one who uses the computer system. So then, those instructions are given in the form of computer programs. Okay, so that computer can do something based on how it has been instructed, so that it requires a computer program. So in this subject, we will discuss about how we can instruct the computer to do a task, or how to we can also discuss how we can problem our general problems, like suppose you want to add two numbers. Okay, you want to create one calculator. So fine, so computer cannot do any calculation by itself unless we are get instruct unless it has been get instructed. So that we must use the computer programming languages to instruct the computer. So like a human being, we use the a communication language, or it's called a communicated languages for um, interaction each other. Fine, so the computer also uses the language to interact with the users. Okay, computer also uses the language to interact with the users. Those languages are called as a computer programming languages. Okay, so those computer programming language that clearly specify the way to carry out any task. Fine. Okay, so anyway, there is a point, the third point is given that a computer cannot solve any kinds of problem by its own. One has to provide a step-by-step solution of the problem to the computer. Okay, then only it can do any it can solve any kinds of problems. Fine. So anyway, as a human being, we use a natural language such as English or Kannada, Hindi, okay, for the communication. Similarly, user communicate with the computer language, it should be understood by it. Okay, so rather the instruction the provided in the form of computer program are developed by using computer or a programming language. So throughout this chapter we'll discuss how the instruction are being given to the computers. Fine. So anyway, let me move on to the next slide. Fine. Here it shows the programming development life cycle. Okay, what we understood in the first slide, that the computer cannot do anything by itself, so that it has to be instructed properly. Okay, so here how we can develop, here we'll discuss how we can develop a program. Okay, so then we first must understand the programming development life cycle. So this life cycle that clearly shows how we can develop a program. Okay, so before starting the process of writing a program, okay, so writing program, it's also called as a coding. So then one who studied computer science in a PUC, so they may find very easy, and so others, those are non-computer science background students, they can also find easy by understanding the concept. Okay, I will explain it clearly, and so at the end of the this chapter we'll come to know that what exactly the programming language is. Fine. So the programmer has to determine the problem that needs to be solved. The first thing is that the one who want to develop a program, one who want to give the instruction to the program, he has to determine the problem that needs to be solved. There are different approaches to problem solving. One common approach is program development life cycle. Okay, so many approaches are there to solve any kinds of problem by the computer. The common approach is that programming development life cycle. So this program life cycle that contains number of steps. You can see the number of steps in oval symbol. Okay, so the process runs in a loop. You can see the process runs in a loop. It starts from a problem analysis, task analysis, and goes on like this. Again, it will continue the steps. Okay, so there is no stop here. It will be go on looping. Okay, so for example, as the current process is completed, new demands appear and the development process commences again. Okay, so the first problem has been solved. Okay, or else it the some part of the problem has been solved, so again we need some more updation on the same problem, or we need an updation for the solution for the same problem. Okay, so we can continue the process again and again. So this diagram is clearly shows the development life cycle of a program. So first, which include problem analysis. Okay, let me explain all these steps one by one. Right, first one is problem analysis. Okay, so in this problem analysis, the one who want to give the solution to the problem, you have to analyze the problem properly. Okay, what the problem is. Fine. So the problem is analyzed precisely and completely. Okay. It before giving the solution to the problem, first one must understand the problem precisely as well as completely. You have uh, to give the proper solution for the any problem. One should understand the problem thoroughly. Okay. So based on the understanding, the developer knows about the scope within which the problem needs to be developed. Okay, that is based on the understanding of the problem, the developer or the programmer knows about the scope within which the problem needs to be solved. Okay, so the first step is analyzing the problem. That means complete analysis of the problem, so that the developer has to understood the entire problem first, then only he can give the proper solution to this problem. Fine. Next step is task analysis. Let's see what actually the task analysis is. So after analyzing the problem, the developer needs to develop the various solution to solve the problem. Okay, so see, for example, for a problem, it's not necessarily contain only one solution. We may find many kinds of solution to the same problem. Okay, let it be, suppose you want to move from Delakate to Mangalore. Okay, or Mangalore city. So we have lot of the problem is traveling from Mangalore, sorry, Delakate to Mangalore. Okay, we can find many number of the routes or the way from Delakate to Mangalore, so that we have to find which is the shortest path. Okay, we can say there are three to five different look that paths. So out of that we have to find the shortest uh, path. Okay, so that whatever the problem is, we need to find very optimized solution to the problem. Okay, so that task analysis, it says that after analyzing any problem, the developer needs to develop a various solution to the given problem. From this solution, the optimum solution, okay, it's called as a optimum solution, is chosen, which can solve the problem comfortably and economically. Okay, so uh, in traveling problem, that means suppose you want to travel from Delakate to Mangalore, so many paths are there, many routes are there. Okay, so one is the longest path, one is a medium path, one is the shortest path. Okay, so the solution here is we have to find the optimum solution, that means which is the shortest path that so through that way we can travel. Okay, that's what the task analysis is, finding the solution which must be solve the problem comfortably as well as economically. Okay, fine. So second step is task analysis. Let's move on to the third step, that is algorithm development. Okay, so what is an algorithm? Algorithm is nothing but a step by step solution to the problem. Okay, step by step solution to the problem, so that it can solve the problem very easily. So after selecting appropriate solution, right, now second step we have we discussed that we need to find an optimum solution to the problem. After selecting appropriate solution, an algorithm is developed by using basic logical selection of the solution. Okay, an algorithm that depicts the solution in logical steps. So logical steps in the sense the sequence of instruction itself. Okay, so the computer may not knowing it's not knowing about the communicative language or the natural languages. Okay, it should be understood by the some kind of programming language, so that the algorithm that depicts the solution in logical steps. So the logical steps are nothing but the sequence of instruction. Okay, further an algorithm can be represented in many ways. Okay, the first way the algorithm is represented by using flow chart. Okay, so flow chart in the sense there there is some kinds of symbols, so by using those kind of symbols we can the one can easily give the solution to the problems. Okay, the flow chart contains some kind of steps, some kind of shapes. Okay, so through that shapes, so we can find the solution to the any problem. Okay, so the algorithm, after development of the algorithm, we can represent those algorithm in a flow charts, or we can also use decision tables for finding the solution to the problem. Okay, so in we'll discuss about a flowchart and decision table uh, for the classes. Fine. Flowchart is very easiest one. Okay, there are some symbols, some shapes are used for understanding the or giving the solution to the problem. Fine. Now third step is development of the algorithm. So once the algorithm has been developed, okay, we can move on to the next step, that is testing the algorithm. So why we have to test the algorithm? So the testing of the algorithm is to identify the major logical errors at an early stage, because the logical errors are often uh, difficult to detect the and correct it later stages. Okay, see, before converting into actual programming, okay, see that step called coding, this step is uh, has to be done after testing the algorithm. So coding in the sense actually we are instructing the computers, okay, how we can solve the a problem. So the algorithm testing, this step before converting an algorithm into before converting the developed algorithm into coding, we should check the accuracy of the algorithm. Okay, that's why this step, the algorithm testing. So this algorithm testing, the purpose of this algorithm testing is checking the is to identify the major logical errors. Okay, any kinds of errors that may occur, so that we need to test the algorithm in the early stages, because it is very difficult to detect any kinds of errors and to correct it later stages. Okay, so once the coding has been finished, very difficult to find out the errors in an algorithm. Okay, so that before converting any algorithm into coding, so the testing has to be done. Okay, so algorithm testing, it is to find out the errors uh, that are often difficult to detect as well as correct it later, so that if there is any error, so we can solve that error in an algorithm testing step. So the anyway, the testing of algorithm that ensures the algorithm is true one and there should not be any abnormal result for the algorithm. Okay, so basically algorithm that ensures the testing of the algorithm that ensures the algorithm is true and it should work for the both normal as well as unusual data. Fine. Okay, so remember we just now we discussed the four different the steps involved in program development lifecycle: problem analysis, task analysis, algorithm development, and an algorithm testing. Okay, once the testing has been done, now we can convert it into a program, or you can convert into a actual coding. So to write a code, there are different languages are used. Okay, so in this semester we will going to discuss about C programming language. So our subject name is problem solving using C. So that, here till here we have discussed about the problem and the solution to the problem. Now we are actually converting it into coding out to the programs. Okay, so here we can use many kinds of programming language. So most commonly used programming languages: programming C++, Java programming, VB.NET program, C#. So many number of programming languages are there, but in our syllabus it is given only about the C programming language. So we'll discuss C programming language and we can write the code in C programming language only. Okay, depending upon the application and the domain and the available resources, a programming can be written using computer language of different level. We can use machine language, can use assembly language, you can use high level language. So these are the terms you are defines the type of the programming language. Okay, it's not much important, but still the coding we have to use some kind of program language. Now most commonly used programming language is high level programming language. Now C++, Java and this kind of programming language that comes under high level programming language. Fine. So anyway, I hope you understood these five steps: problem analysis, task analysis, algorithm development, again algorithm testing, and the coding. Okay, next step is testing and debugging. So once the program has been written, we need to test the program whether the written program or the coding is correct or not. It is a common for the initial program code to contain errors. A program compiler and the program design test data machine test the code for syntax error. Okay, so there are some kind of the syntax, the structures are there for writing the code. There is no predefined structure for development of the algorithm, but whereas for coding there is a some kind of syntax, some kind of structures are there. We need to write the program according to the structure which has been defined. Okay, so there may be some kind of error, so that we need to test the errors in coding. Okay, the result obtained are after the testing and debugging, the result obtained are compared with the result calculated manually from these test data. Okay, so result obtained after the testing that has to be compared with the result calculated manually from this test data. So once the coding has been over, we can test and debug. So we can manually check whether the coding has been given a proper answer or the proper result or not. So depending upon the complexity of the program, so we can do several stages of or the several rounds of testing. Okay, so several rounds of testing may be required depending upon the complexity of the program. If the program is very small, so the small rounds of tests are enough. If the program is very big, so we have to take many rounds of testing. Okay, so testing is done after coding. Why the testing is done? To check the errors in a program. Okay, to check the errors in a program, we can do a testing. Okay, so there are some programs are there for testing the programs, that's called as a compiler. So after writing program, we need to compile our program. So the result of the compiler is it will give you some errors, so we can overcome the errors by doing testing and debugging. So once the testing has been done, so next step is the documentation task. So documentation is uh, a program that enables a user to operate the program correctly. See why the documentation has been done. So once the program is free from all the errors, so it is a duty of the program developer ensure that the program is supported by the suitable documents. Okay, so we know for taking the admission of any admission to the any course, okay, we need some kind of documents. So we need some mask card, thesis, okay, etc. That is to ensure that this student is has been completed their previous course successfully. So so that we need to have some kind of documentation. Similarly, once a program is an error free, so that the programmer or the developer has to maintain the proper documentation. So this documentation should be supplied to the program users. So one who uses this program has to be supplied, and the documentation program of a program that enables the user to operate the program correctly. So why the documentation is required? The objective of the documentation that enables the other users to understand the program clearly, so that they may, if necessary, can modify and correct it some other than the original programmer. Fine. So for example, suppose you are a programmer. Okay, so you are working with a particular project. Let it be you are working with a particular project. So after some time, let it be you work for 3 years. Okay, after that you are going to skip that job, or you want to skip that uh, company or that project itself. Fine. So that new one will come, a new one will join. So to understand the entire the task of the coding, okay, so that new one can see the documentation, he can understand what actually how actually the coding has been done. Fine. The steps for giving the solution to the problem has been done can be understood by looking at the documentation. So it is clear that the documentation that enables you other persons to understand the program clearly, so that if necessary they can be modified and corrected in, uh, by someone other than the original program. So other than the original programmer, okay, the other person can also make the modification on the original program itself. So next step is that implementation. Okay, I hope you understood the usage of the documentation. Keeping the documentation for that other person can also do the modification on the original program. So implementation uh, is the program is installed on the end user's machine, and the user is also provided with all the essential documents in order to understand how the program works. See, I think you're all using the mobile phone. So in mobile phone you have a lot of applications, a lot of the softwares. Okay, so now you have, if you are using that application, so that step is nothing but this one, implementation. So mm, you are install those application into a mobile phone, so that is called as a implementation. So that, see, suppose I have developed an application, let it be in WhatsApp. Okay, so it is done in the that is gone through in these stages itself: problem analysis till the documentation. The next step is that I have to make it available for the users, so that step is nothing but an implementation. So the implementation can be viewed as a final testing, because only after using the program the user can point out the drawbacks and the report them to the developer. So based on the feedback from the user, the programmer can modify or enhance the program. See here, implementation. Suppose now you are using WhatsApp program, so you may find some kind of difficulties, some kind of errors or the problems while using the WhatsApp application. Okay, so that we can give the feedback to the developer of the WhatsApp application. So implementation, it the purpose of implementation and the result of the implementation can be viewed as the final testing, because only after using the program the user can point out the drawbacks. Okay, so if there is any drawbacks, any problems in the program or in the coding or in the working of the any kinds of application, okay, we can identify, and that can be raised by the end users. Okay, so that based on the feedback from the users, the programmers can modify the or enhance the program. Okay, so there is a implementation stage. So once the implementation is completed, that means after implementation we need to maintain or enhance the entire system. Okay, so why the maintenance is required? The term maintenance, the meaning of the term maintenance. So we need to maintain anything so that we can keep any actions or any things proper manner, so that it can increases the efficiency as well as the performance. Okay, so that the maintenance maintained by taking the care of the changing the requirements of its user and the system, so that the program should regularly enhanced by the additional capabilities. So sometimes this phase, the maintenance phase, also concerned with detecting the and fixing the error which were missed in this testing phase. Clear? So maintenance after a program is implemented, it should be properly maintained by taking care of all the changing requirements of its user and the system, so that it can be regularly enhanced by adding additional capabilities, so that we can add some additional capabilities to the existing program. So see, I will give a general example of an application. Suppose you are using WhatsApp. So during the release, the first release of WhatsApp, okay, it has only some very few features. Okay, there was no the status option, there was no the sleep, that is read received options. Okay, many other options were not there. We cannot transfer documents like files, the PDF files, word files. So it was not possible during the first release of the WhatsApp application. So later on, it all those the features were get added. So what does it specify? So the program is regularly enhanced so that we can add additional capabilities, so that the first version of any kind of application may have only few features, so we need to upgrade this so that it can solve the it can meet all the requirements of the end user, so that it has to be get maintained as well as it has to be enhanced. Okay, so followed by, so if any enhancement the maintenance is required, again we are going back to the problem analysis steps. So the steps is this phase also concern detecting and fixing the errors which were missed in the testing phase, and since if there is any the changes is required, the step generates the user feedback, the programming lifecycle continues. Okay, this program lifecycle will continues as the program is modified or reconstructed to meet the changing needs. Okay, so if any other changes are required, again that those changes are get analyzed, and again it goes to the all the step again and again, come back to the maintenance and enhancement step. And again, if any further changes is required, the enhancement is required, again gets looped. Fine. So anyway, that's all about the programming development life cycle. Okay, very important, these number of steps. Okay, so there are 9 steps are there. So once again I'll repeat: programming analysis, analyzing the program thoroughly, and task analysis, finding the solution for the uh, problem, then developing the algorithm, so that those algorithms that gives the optimum solution, so that we can represent those solution in a diagrammatic way by using flowchart or a decision table. Then we can check the availability at the algorithms. Okay, this testing phase that ensures our algorithm is perfect to solve the solution. So once the testing has been done, algorithm testing has been, we can implement by using any kind of a programming language. So once coding and the debugging, the phase has to be done once the coding is been finished. So coding, the testing and debugging ensures that uh, there is no errors in a program. Fine. So next step is documentation, that keeping the documentation in order to do any changes by the other users. Then implementation, so making use it to the end users, so that end user can use this application or the softwares. Then followed by maintenance and enhancement, so we have to maintain in order to enhance any kind of changes it is required in a feature. Then again, if everything has been clear, then no need to go for the problem analysis phase. If any changes or updation is required for the same problem or solution to the same problem, we can again come back to the problem analysis and we can go through all these steps again. Okay, so that's all about programming development life cycle. Fine. Okay, anyway, so let's move on to the next step, that is algorithm. So third step, we have discussed about algorithm in programming program development life cycle. Let's see what actually the algorithm is. So, algorithm is a finite sequence of explicit instruction that, when provided with a set of input values, produces an output and then terminates. Okay, so simple term, an algorithm is defined as it's a finite number of steps. So, in order to give any solution to any kinds of problems, so there must be some kind of steps. So it has to be solved with the finite number of steps. There should not be an ambiguity. There should not be any ambiguity. That means, so if you're if you're not finding any solution to the problem, so that may lead to the an ambiguity, so that it has to be stopped in a finite number of steps. So the solution to the problem has to be stopped in a fixed number of steps, so that algorithm is defined as finite number of steps to solve the problem. Okay, in simple term, finite sequence of steps to solve the any kinds of problem. In general, what we can explain, it can be explained like this: finite sequence of explicit instructions, so instructions that given to the system to solve the problem, that when provided with a set of inputs, okay, when the inputs are applied, it has to provide an output and then terminates. Okay, so now we are giving some input, and it has to provide the output as we expected. Okay, so if it does provide the output for this problem as we expected, then we can terminate. That what the algorithm is. Okay, so here we can see some properties of an algorithm. See, we have to understand the algorithm and the program. Algorithm is slightly different than the program. So algorithm are not a computer program, as they cannot be executed by the computer. Fine. So algorithms cannot be executed by the computer. So we need to remember this term: algorithm cannot be executed by the computer. It has to be done manually by the one who want to find a solution to the problem. Okay, so let's see some of the properties of an algorithm. So first one, there must be no ambiguity in an instruction. Ambiguity means there must not be any kind of confusion in an algorithm. So if you want to find a solution to the problem, so there must be any finite number of steps. So by using only those number of steps, we have to find the solutions. That's why there should not be any confusion, there should not be any ambiguity. Okay, so the algorithm must be unambiguous. Okay, so second one, there should not be any uncertainty about which instruction is to be executed next. So we have to make sure that which instruction has to be executed next, so that there should not be any uncertainty. So we have to provide, so for example, there are 10 lines or 10 steps. Okay, so the first step, second step, third step is okay, it should go on like this. Fine. And you can have some kind of option. For example, you are in the fifth step, again you can come back to the second step. Clear? So it's also possible. So now you are in second step, you can go to the step 7. Clear? Or we can go to step 6. Clear? So it is what the algorithm should be. So there should not be any uncertainty which instruction has to be executed next. Fine. So after writing the any algorithm, it should be terminated after finite number of steps. So for example, there are only 10 steps, so we need to provide solution to this problem only within those 10 steps. It should not exceed that. That's why the algorithm should be terminated after a finite number of steps. Okay. Similarly, the next property is that it must be general enough to deal with any contingency. Okay. So it should be a general enough. There should not be any kinds of the complexity in an algorithm. So a general solution must be given to the given problem, so that there should not be any kind of uh, contingency. Okay, so it must be general enough to deal with the any kinds of contingency. If any problem arises, so in general we need to solve the solution, we need to solve the problem. Okay, so anyway, these are the properties of an algorithm. uh, I hope you understood the why algorithm is used, what actually the algorithm, and properties of algorithm. Okay, so that this definition, fine, the definition of an algorithm very important for 2 marks. Okay, so here it is given in only two lines, like it's finite sequence of instruction that is provided when an set of input is produced and should provide an output. Okay, finite sequence of instruction, okay, for the input values, that means the set of input values should provide some output and then terminate. Okay, that's what an algorithm is. Clear? Okay, let me give an example how actually algorithm works. So here different algorithm may accomplish the same task with a different set of instruction in more or less time or space or efforts. Okay, see, suppose you are finding the solution for a problem. So for a problem, same problem, we can find different solution. Okay, what we discussed earlier, problem analysis after problem analysis, implementing algorithm. So there we discussed that we have to find an optimum solution. So optimum solution that includes less time. Okay, the problem has to be solved within less time and less space and less effort. Okay, so that gives the optimum solution to the problem. Okay, let me give a small example. Okay, so two different recipes for preparing tea. Let it be, we are going to prepare a tea. One, add the sugar while boiling the water. Now our solution is to sorry, our problem is to preparing a tea. So what is the recipe for preparing tea? Right, so we have the different solution for preparing a tea. The first one is add the sugar while boiling the water, and other one is after boiling the water, produces the same result. Okay, that means we can add this sugar while boiling the water or after boiling the water. Okay, but the end result is same. Okay, understood? So we can add the sugar while boiling, or we can add the sugar after boiling the water. Okay, but the end result is same. So the performance of the algorithm correctly does not guarantee a solution if the algorithm is flawed or not appropriate to the context. Clear? So that means uh, we can find the solution in any way. Okay, so in in this problem, that is preparing tea, we have a two solution for preparation of the tea, but which one is which one requires a less time and space and efforts, that we you can choose for the further implementation. Okay, so anyway, let me give a real-time example of an algorithm. Okay, so here is an algorithm for uh, to determine the largest of three numbers. Okay, so I hope you understood this slide. Okay, and the properties as well as a small example. Now we are working with some example, real-time examples. So algorithm to determine the largest of three numbers. Okay, I hope you understood the problem to determine the largest of three numbers. Okay, as we discussed earlier, algorithm that contains a see number of steps is a finite number of the sequence of instructions. So here are the sequence of instructions are there. So first we can begin with start. Okay, then read three numbers. Okay, we have to take three numbers. Let it be number A, number B, and number C. Okay, so read this problem first, the algorithm to determine the largest of three numbers. We have to determine, our problem is to determine the three largest of three numbers. Okay, so let me take those three numbers as A, B, and C. Okay, anyway, find the larger number between A and B and store. The first step is, okay, we can find the larger number between A and B. Okay, so we cannot compare all these three together. Okay, computer cannot do like this. Fine. So as a human being we can do, but the computer cannot do like this. So we have to find the larger number between A and B, and then we can store it in a variable called max AB. Okay, let me give some example. Okay, let it be let me take some number. Okay, A is equal to 50 and B is equal to 30. Okay, C is equal to 60. Okay, so these are the three number. A is equal to 50, B is equal to 30, and C is equal to 60. Okay, so first what I have to do, read the three numbers. Okay, I can read the three numbers A, B, C. I have given the value 50, 30, and 60 respectively. Right, now find the larger number between A and B and store it in max AB. So A is 50, B is 30. Okay, so now I got the largest number. So larger number is 50. Between A and B, the larger number is 50. So that, so max AB going to store the value 50. Okay, find the larger number between A and B. A value is 50, B value is 30, and store that value in max AB. So now between A and B, the maximum number is 50. Okay, now so there is one more variable is remaining, that is C. Okay, so again I have to find the number between uh, AB and C. Okay, so here it is clear that in this step it is clear that B is smaller than A, so then I can check between A and C. No need to check between B and C, right? Because we already check A and B, we got the result that A is greater than B. So that it is sure that B is less than A. Now I need to check whether A and okay, whether C is less than A. Okay, let me go to the next step. Find the larger number between max AB. So what is the value of max AB? We got the value here, that is 50. Okay, then C. What is the value of C? That is 60. Okay, now find the larger number between max AB. Max AB is 50. Okay, that is the result of A and B. And now C, we have the value for C, that is 60. Now we can store the final result in max. So what is the value of max? That will going to be a 60. Okay, the 60 is the larger number between these three number. That means C is the larger number. Let's see, A is 50, B is 30, C is 60, and the final result, it is 60. Max equal to 60. Okay, so now finally we can display the result max. Okay, that is 60. Now stop. We have found the solution for this problem, so then we can terminate. Right, so once again I will repeat. Start. Okay, so we have to determine the problem first. Okay, the problem is finding the largest of three numbers, where we have three numbers A, B, and C are the variable. Value of A is 50, value of B is 30, value of C is 60 again. Okay, so we have to find between A and B. Okay, then we have to find between A and C. Okay, so if this is the case, if let it be B value is 50 and A value is 30, then again we need not to check between A and C, we need to check between B and C. But here it is sure that A is greater than B. Okay, so that result we got in the first step. Then second step, the larger number between max AB is 50 and C is 60, and store it in max 60. Okay, the final result, that 60, that is a value of variable C, that is going to store in max. Now we can display the max, that means 60 is the largest number, so that I can stop the algorithm. Okay, we found the solution for this problem, so I can stop it. Right, I hope you understood this problem, okay, or this algorithm. Okay, let me move on another one. I will explain the second algorithm. Fine, so algorithm number 2, algorithm to count number of odd, even, and zeros in a list of integers. Okay, so read the question again. Algorithm to count number of odd, even, and zeros in a list of integer. Okay, so first we have to count number of odd, number of even digits, and number of zeros. Okay, in a list of integers. So integer in the sense that is number, it may be a positive or a negative, it may be a positive or negative, but it should not be a any fractional number. Let it be 36.53. Okay, so this is not a integer. Okay, there is a, because there is a fractional point. Okay, so we need to have an integer, understood? So integer should not contains a fractional point. Okay, let me remove this. Okay, so here let me take one number 4103. Okay, let it be this is a number, our number is this. So in this number there are four digits. First digit is 4, second digit is 1, 0, and 3. Now what I have to do, I have to find the number of odd, even, and zeros in a list of integer. Okay, there are four numbers, I have to find this. Okay, now the first step is start. Okay, then take input, read a number. So our number is this. Okay, I have to read a number 4103. Okay, this is my number. Okay, before processing this, okay, before processing this, fine. So before processing this, I have not knowing about how many numbers of, or how many odd numbers are there, how many even numbers are there, how many zeros are there, so that I can take one variable e count. E count in the sense even count. Even count is set as 0, zero count is set as 0, sorry, odd count is set as 0, and zero count is set as 0. Okay, initially these three numbers are set to be 0. E count is 0, o count, that means odd count is 0, z count is also 0. Fine. Okay, so later this value will be get changed according while we are processing on this number. Okay, first check if number is equal to 0. Fine. If a number is equal to 0, see this number is not equal to 0, right? So basically this number is not equal to 0. See here 4103, it is not equal to 0, right? So here it becomes like this: 4103 equal to 0. No, it is not. So zero count will be 0 itself. Okay, and again we can check it. Else if number is mod 2 equal to 0, no, it is not a 0. Okay, number mode, see number mode, number means 4103. 4103 mode, it's called as a modular division, not a simple division. Mode 2 equal to 0. See, the result of modular division is a remainder. Okay, let me give one a simple example of 4. Okay, 4 mod 2 equal to 0, because the 4 it wholly divided by 2, that's why remainder is 0. Let it be 3 mod 2. Okay, the result of 3 mod 2 is 1, because 3 cannot be wholly divided by 2. Okay, 2 ones are 2 and the remainder is 1. 2 ones are 2, the remainder is 1, so that it is not equal to 0. Okay, so e count plus plus, okay, that also it will not be going to increment, when that also remains 0 only. Fine. Else uh, else we have one more statement, o count. Okay, so here there is no condition is given, so that I can say 413 4103 will be equal to is a odd number. So their value initially it was 0, now it is get incremented. So plus plus stands for increment by 1. So O count becomes 1. Clear? O count becomes 1. That means 4103 is not a even number. It's not equal to 0. It is equal to odd. Okay. So 4103 is equal to 1. Okay. So let me give one more example on this. Okay. So let me give value 6. Okay. A single digit number. Single digit number. E count equal to 0. So our number is this. Okay. E count equal to 0, 0 count equal to 0, Z count is equal to 0. If number is equal to 0, no, this condition is false. That means 6 equal to 0, no, this is not. Fine. So then 0 count will be let it will remain as it is 0 itself. Okay. Now I can check 6 more 2 equal to 0. Yes. Okay, because 6 wholly divided by 0, so that the remainder after division of 6 by 2 is 0 itself. Okay, the remainder is 0, so that this is right. Okay, this condition, if number, else if number is 6. Okay, 6 mod 2 equal to 0, then E count equal to 1. This becomes 1 because here it was 1, sorry, here it was 0, now it becomes plus plus. Now so the value becomes 1. Okay, so the given number is even. Okay, because if any number, so a simplest solution for finding the even number is that if a number is divided by 2, then it is a even number, else it is a odd number itself. Okay, 2, 4, 6, 8, you know, right? Those are the even number. If any number it is directly divided by 2, then it is a even. Okay, so that 6 can be divided by 2, so the remainder is 0, so E count becomes 1. So this is cannot be executed. Fine. So once a solution has been found, we can exit. Okay, so that's all about this algorithms. Fine. Anyway, so that's all about today's session. I will wind up this session. If you have any kinds of doubt, you can write a comments, and you can also message in WhatsApp or in a Google uh, Classroom. Okay, so we'll solve this problem. Okay, so thank you for listening this video, watching this video. Thank you all. Okay, we'll see you in next session.